लेवन आज नुआ चैप्टर पढ़िबा फिनोल्स पढ़िबा P H E N O L S फिनोल्स फिनोल पढ़िबा देखो चैप्टर ता अल्कोहल फिनोल एंड इथर्स अल्कोहल सब जाई तापर हम फिनोल पढ़िबा these are the series of organic compounds having general formula AROH. Here AR represents an aryl group, ARYL, aryl group. Here OH is directly linked, directly attached to benzene ring. It is your benzene ring. Here OH is directly attached to benzene ring. It is called phenol. Phenols are also known as carbolic acids. CARBOLIC. Carbolic acid. It is due to drying away snakes. Carbolic acids. Phenols are otherwise known as carbolic acids. Methyl phenol is called cresol. Here it is phenol. Methyl phenol CH3OH. In methyl phenol it is called cresol. Depending upon the position of the methyl group and methyl group as compared to H group, it is cresol is further divided into three types. It may be orthocresol, metacresol, or paracresol. It is your orthocresol, then it is your orthocresol, CRESOL, then metacresol, when both are present para to each other, that is 1 3 position, 1 and 3 position. It is your metacresol, then paracresol, when the position are 1 4, OH is present at this position and CH3 is present at this position. It is your orthometa and paracresol. Methyl phenol is called cresol, orthocresol, metacresol, paracresol. Depending upon the position of the methyl group as compared to the OH group. When the position is 1 2, then it is orthocresol. When the position is 1 3, then it is called metacresol. When the position is 1 4, then it is called paracresol. Depending if two OH groups are present, it is a nuclear phenol is a nuclear substituted compound because OH group is directly attached to the nucleus, so it is a nuclear substituted compound. Nuclear substituted compound. Phenol is a nuclear substituted compound. When two OH groups are present, or when two OH groups are directly linked to benzene ring, then it is called catechol, resorcinol, or quinol, depending upon the position of the two hydroxy group. It is your, if two OH groups are present, just at one at number 1 position, another at number 2 position. It is the catechol, CATECHOL, catechol. If the position is 1 and 3, it is your 1 and 3. 1 is present, OH, it is your number 3 also occupied by OH group. It is your resorcinol, RESORCINOL. It is your resorcinol, catechol, resorcinol. If it is at para to each other, if two OH groups are para to each other, it is called quinol, QUINOL. Quinol. If three hydroxyl groups are attached, then it is called pyrogallol. This is the graphic formula of pyrogallol. Here three OH groups are present, one at number 1, second at number 2, and third one at number 3. It is your pyrogallol, pyrogallol, GALLOL, pyrogallol. So this phenol is a nuclear substituted compound. Here OH group is directly linked to the benzene ring, so it is a nuclear substituted compound. It is otherwise known as carbolic acid and it is used to dry away snakes. Methyl phenols are known as cresol. Depending upon the position of the methyl group as compared to the OH group, it may vary. It may be ortho, meta, or para. When OH group and CH group are present, number at 1, 2 position, then it is called orthogonal. If these two are present in 1 and 3 position, then it is called metagonal. If these two are present 1 and 4 position, then it is called paragonal. When two hydroxyl group or when two OH groups are present or directly attached to the benzene, then it may be called catechol, resorcinol or quinol, depending upon the position of the OH group. When two OH groups are present at number 1 and number 2 position, then it is called catechol. When it is present at, if one is present at number 1 and another is present at number 3, then it is called resorcinol. When one is present at the number 1 position, another is present at number 4 position, it is called quinol. Catechol, resorcinol and quinol all contains two OH groups. Your two OH groups are directly attached to benzene. If three OH groups or three hydroxyl groups are present or directly linked to the benzene, one at number 1, another at number 2, and third one is at number 3rd position, 1 to 3, then it is called pyroganol. General methods of preparation. General methods of preparation of phenol. General methods of preparation. General methods of preparation. General methods of preparation of phenol. Phenol आपण तयारी करी परिबा. First आपण होची hydrolysis of aryl halides. Hydrolysis of aryl halide. Hydrolysis of aryl halide. Hydrolysis means addition of water. Hydrolysis of aryl halide means it is your chlorobenzene. It is an aryl halide. It is your chlorobenzene. Your halogen atom is directly attached to an aryl group. Chlorobenzene. When this hydrolysis is generally carried out in presence of an alkali or a base, sodium hydroxide. So when an aryl halide is hydrolyzed in presence of aqueous sodium hydroxide, then sodium phenoxide is formed, which on acidification to produce phenol. The aryl halide की सोडियम हाइड्रोक्साइड aqueous सोडियम हाइड्रोक्साइड से रिएक्शन कले सोडियम फेनोक्साइड हबो. सेकंड स्टेप रे सोडियम फेनोक्साइड की एसिडिफिकेशन कले फिनोल हबो. आ ई प्रोसेस को कहा जाए डाउस प्रोसेस. DO W अपोस्ट्रोफ से डाउस प्रोसेस. डाउस प्रोसेस कहले कोन हाइड्रोलिसिस ऑफ aryl halides. Aryl halide की hydrolysis करबा in presence of a base aqueous sodium hydroxide. Aryl halides is your chlorobenzene is an aryl halide. Chlorobenzene when it is hydrolyzed in presence of aqueous sodium hydroxide NaOH, then sodium phenoxide is formed. Your minus NaCl, your OH group minus NaCl, sodium phenoxide when sodium phenoxide is formed, it is your sodium phenoxide ONA, sodium phenoxide. Here H combines with this HCl, HCl is removed. Sodium phenoxide plus HCl. Then sodium phenoxide is your chlorobenzene. CHLORO, chlorobenzene, BNZNE. Chlorobenzene, when hydrolyzed in presence of sodium hydroxide, NaCl, then you have to take two molecules of sodium hydroxide. One NaCl is replaced. Your one NaCl is replaced. NaCl is replaced H2O2. One water molecule is eliminated. As a result, O is remaining behind here. O combines O phenochlorobenzene. When reacts with two molecules of sodium hydroxide, then sodium phenoxide is formed. Sodium phenoxide PHENO. Sodium phenoxide is formed. Sodium phenoxide is formed. In second step, this is sodium phenoxide on acidification. This is sodium phenoxide ONA on acidification when it is treated with HCl. And NaCl removes as a result phenol is formed. So phenol is formed, and this process is called Dawes process. Here, chlorobenzene is treated with aqueous sodium hydroxide. Two molecules of sodium hydroxide. As a result, one molecule of NaCl is removed. One molecule of water is removed from your this O. One O and this one Na molecule combined to form ONA. As a result, sodium phenoxide is formed. When sodium phenoxide on acidification, when it is treated with HCl, then phenol is produced. This chlorobenzene is also hydrolyzed in presence of a metal, that is copper, at 400 degrees centigrade to form phenol. When chlorobenzene, this can also be prepared from a chlorobenzene hydrolysis of aryl halides. Your alkaline Dawes process is your alkaline hydrolysis. Here it is your chlorobenzene. If you take chlorobenzene, here it is chlorobenzene. When it is hydrolyzed, when chlorobenzene is hydrolyzed in presence of metallic copper at 400 degrees centigrade, then HCl removes. As a result, phenol is formed. Phenol is formed, but this process is not called Dawes process. Dawes process is alkaline hydrolysis of sodium chlorobenzene. Here chlorobenzene in Dawes process, chlorobenzene is treated with sodium hydroxide to form sodium phenoxide. In second step, sodium phenoxide on acidification produce phenol. But in this case, chlorobenzene when hydrolyzed in presence of metallic copper at 400 degrees centigrade, then phenol is formed. So this is about the hydrolysis of aryl halides. Then come to the second one, that is from sodium salt of benzene sulfonic acid. From sodium salt of benzene sulfonic acid. Number 2, from sodium salt of benzene sulfonic acid. Benzene sulfonic acid, HCl sulfonic acid. Sodium salt of benzene sulfonic acid. When sodium salt of benzene sulfonic acid is treated with sodium hydroxide at 300 degrees centigrade, then sodium phenoxide is formed, which on acidification produced phenol. When sodium salt of benzene sulfonic acid, it is your benzene sulfonic acid, C6H5SO3H. It is called benzene sulfonic acid. Sodium salt means your hydrogen is replaced by sodium. So it is the sodium salt of benzene sulfonic acid or sodium benzene sulfonate. It is called sodium benzene sulfonate. Sodium benzene sulfonate. When sodium benzene sulfonate is treated with sodium hydroxide, that is NaOH, then sodium phenoxide is formed. Sodium phenoxide ONA. Sodium phenoxide is formed. Na2SO3 is replaced. Na2SO3 plus Na2SO3 sodium sulfide with water H2O. It is your sodium phenoxide. Sodium phenoxide. PHNOXide. Sodium phenoxide. When sodium benzene sulfonate is treated with sodium hydroxide at 300 degrees centigrade, then sodium phenoxide is formed. Sodium phenoxide on acidification. Sodium phenoxide on acidification. It is sodium phenoxide on acidification when it is treated with HCl, then phenol is formed. Phenol OH is formed and then NaCl is replaced. Plus sodium chloride NaCl. NaOH. Phenol PHCl phenol plus sodium chloride. This is your second general method of preparation, that is from sodium salt of benzene sulfuric acid. Then third one from benzene diazonium chloride. How you can prepare phenol from benzene diazonium chloride. Phenol from benzene diazonium chloride. Phenol from benzene diazonium. Number third, from BDC, from benzene diazonium chloride. From benzene diazonium chloride. From benzene diazonium chloride, or you can say BDC, benzene diazonium chloride. Benzene diazonium, how can you prepare phenol from benzene diazonium chloride? Paisa disi. When benzene diazonium chloride is heated with, when benzene diazonium chloride is heated with boiling water, then phenol is produced. Benzene diazonium chloride, it is your benzene ring. Benzene diazonium chloride, N2 plus Cl minus, it is your BDC, benzene diazonium chloride. When it is hydrolyzed or when it is boiled, heated with boiling water, when it is heated with boiling water, then H combines with this Cl, Cl is formed, N2 is replaced, OH comes to this part. As a result, phenol is produced. It is your phenol plus, H combines with Cl from HCl, then N2. So phenol is produced. This is your third general methods of preparation. When benzene diazonium chloride is treated with boiling water, then phenol is produced. Your H combines with Cl, HCl is formed, N2 is replaced, OH linked to this benzene ring to form phenol, HCl and nitrogen are produced. So this is about from benzene, preparation of phenol from benzene diazonium chloride. Then fourth one from cumin. Fourth one is from cumin. Fourth one is from cumin. Fourth general methods of preparation, that is from cumin. Cumin is your isopropyl benzene, it's called cumin. Isopropyl benzene is called cumin. Isopropyl benzene is called cumin. First, you have to prepare cumin from benzene. When benzene reacts with propylene, then cumin is formed. It is your benzene. When benzene reacts with propylene is your CH3, single bond CH, double bond CH, or propylene. When benzene reacts with propylene in presence of anhydrous aluminum chloride, anhydrous aluminum chloride AlCl3. When benzene reacts with propylene, it is your benzene. When benzene reacts with propylene, PRO-PYLene. When benzene reacts with propylene in presence of anhydrous aluminum chloride, then isopropyl benzene is formed. It is your benzene ring, isopropyl. This CH linked to this position. One side contains CH3, your one hydrogen atom released from this position, attached to this position. As a result, CH3 becomes CH3. देखो इटा CH3 थिला ए जगह तो लागुची तो जो जगह लागुची तो H बार वेटिंग H बार से H तक CH2 से लागला CH3 ला इटा ला isopropyl benzene. Isopropyl benzene. It is known as cumene. C-U-M-E-N. Cumene. So, from cumene, how it is a preparation of cumene. Cumene can be prepared by the action of benzene with propylene in presence of anhydrous aluminum chloride. When benzene reacts with propylene in presence of anhydrous aluminum chloride, then isopropyl benzene or cumene is formed. Our general method of preparation that is from cumene. When cumene is oxidized by aerial oxygen at 130 degrees centigrade, aerial oxygen when this isopropyl benzene or cumene is oxidized by aerial oxygen at 130 degrees centigrade. 130 degrees centigrade and aerial oxygen. When cumene is oxidized in the presence of aerial oxygen at 130 degrees centigrade, then cumene hydroperoxide is formed. Then cumene hydroperoxide is formed. Which when treated with dilute sulfuric acid, then mixture of phenol and acetone formed. Phenol होगा और acetone होगा. Isopropyl benzene की by cumene की यदि aerial oxygen presence से oxidation करा जाए at 130 degree centigrade, then cumene hydroperoxide first होगा. Then this cumene hydroperoxide, when treated with dilute sulfuric acid, then phenol is formed along with acetone. It is a commercial method of preparation of phenol. Phenol can be prepared by large scale by this process. So it is called commercial method of preparation. That means phenol can be produced in large scale by this process. From cumene. First, cumene is prepared by the action of benzene with propylene in presence of anhydrous aluminum chloride. Then isopropyl benzene, it is your isopropyl benzene or cumene. It is your isopropyl benzene, CH3, it is your CH3, it is your isopropyl benzene. When isopropyl benzene is oxidized in presence of aerial oxygen at 130 degrees centigrade, then cumene hydroperoxide is formed. Then cumene hydroperoxide is formed. Then cumene hydroperoxide is formed. Then cumene hydroperoxide, this is the formula for cumene hydroperoxide. It is your benzene, here CH3, CH3. Oxygen atom, second oxygen atom, hydrogen atom. It is your cumene hydroperoxide. Cumene hydroperoxide. Cumene hydroperoxide. It is your isopropyl benzene by cumene. When cumene is oxidized by aerial oxygen at 130 degrees centigrade, then cumene hydroperoxide is formed, which when treated with dilute sulfuric acid, dilute H2SO4, dilute sulfuric acid, then phenol is formed, phenol OH is formed with acetone. CH3 C double bond you bond भांगी जीवो OH लागी जीवो phenol हला CH3 CO plus acetone CH3 CO acetone. It is your acetone, it is your phenol. Phenol हला आगे तुम्हारा acetone हला acetone and phenol. This is about the general methods of preparation. Then come to the physical properties. Physical properties. Physical properties. Physical properties. Physical properties. Number 1. Phenol is a colorless crystalline solid having melting point value of 43 degrees centigrade. Number 2, it is fairly soluble in water. It is fairly soluble in water. Fairly soluble in water due to formation of hydrogen bonding. Number 3, it has a characteristic order. It has a characteristic. It has a characteristic order. And it is a characteristic order and poisonous in nature and poisonous in nature. Number 4, it has seen that orthonitrophenol has lower MP value. Orthonitrophenol has lower MP value, melting point value than meta and M and P, meta and paranitrophenol. It is due to the proximity of OH group and NO2 group. In case of orthonitrophenol, this is the formula or structural formula of orthonitrophenol. It is a phenol. If nitro group is present at the ortho position to phenol, then it is called orthonitrophenol. Second one is paranitrophenol, metanitrophenol. Here it is called metanitrophenol. Third one is called paranitrophenol. It is the structural formula of paranitrophenol. In case of orthonitrophenol, intramolecular hydrogen bonding is present. The hydrogen bonding is present in intramolecular position. But in case of metanitro and paranitrophenol, the hydrogen bonding is example of intermolecular hydrogen bonding. Intermolecular hydrogen bonding with water, intermolecular hydrogen bonding. But here intramolecular hydrogen bonding is present, which can be represented like this. It is your OH group, your nitro group N double bond O, single bond O minus, this is your plus this N. The dotted line indicates intramolecular hydrogen bonding. Intramolecular. The hydrogen bonding is present within the molecule, same molecule. It is called intramolecular hydrogen bonding. Now compound showing intramolecular hydrogen bonding has lower Mp and Vp value than compared to the intermolecular hydrogen compounds having intermolecular hydrogen bonding. Here the OH group and NO group are present very close to each other, it is called proximity effect. PROXI proximity effect. As these two are present very close to each other and there exists an intramolecular hydrogen bonding, so the orthonitrophenol have lower Mp, lower melting point value than meta and para-nitrophenol.